Dear students, in this lecture we are going to learn about the radius of curvature, center of curvature, and how to find the evolute of parabola. The first problem is, show that in the parabola y squared equal to 4ax at the point T, the radius of curvature denoted by rho is equal to minus 2a multiplied with 1 plus t squared the whole power 3 by 2, and the center of curvature, that is the coordinates of the center of curvature, is x comma y, where x is equal to 2a plus 3a t cube and y is equal to minus 2a t cube. So we have to prove this. We have to prove that the radius of curvature is equal to this, and we have to prove that the coordinates of the center of curvature is this. Also, they are asking us to deduce the equation of the evolute. So we are going to learn these three in this video. So the formulas used is, the formula for radius of curvature is rho is equal to 1 plus dy by dx the whole squared whole to the power of 3 by 2 divided by d squared y by dx square. We have already seen how to find the radius of curvature in our previous videos. And then the center of curvature is given by the coordinate is x comma y, where the value of x is small x minus y1 multiplied with 1 plus y1 squared divided by y2, and capital Y is equal to small y plus 1 plus y1 squared divided by y2, where y1 and y2 represent the derivatives of y. This is the first derivative and this is the second derivative, and x comma y will represent the point at which we have to find the center of curvature. So we have already seen problems on center of curvature too. Now here in this video we are going to learn a new concept called evolute. So all these three we are going to find for a parabola. Yes. Now here it is given that the equation of the parabola is y squared equal to 4ax. We all know this. But we also know that there are parametric equations for parabola. What are they? The parametric equation of a parabola is x is equal to at squared and y is equal to 2at. So this is the parametric equation of the parabola. So at these points we are going to find the radius of curvature and the center of curvature. Now actually to find radius of curvature we need dy by dx and d squared y by dx square. Now dy by dx can be written as dy by dt divided by dx by dt. That is, here x and y are in terms of t. So in that case we can't directly find dy by dx, and for that reason we are taking dy by dx to be equal to, first we have to differentiate y with respect to t divided by the differentiation of x with respect to t. So this will give us dy by dx. So let us find that now. So x is given as at squared. So when we differentiate this x with respect to t, we get dx by dt to be equal to a and the differentiation of t squared. So that is 2t. So therefore dx by dt will be 2at. And then y is given as 2at. So the differentiation of y, that is dy by dt, with respect to t will be, this 2a is a constant, so 2a multiplied with the differentiation of t. So what is the differentiation of t? It is 1. So that is equal to 2a. So now we have evaluated dx by dt and dy by dt. These two now we have to substitute here and we have to find dy by dx. Let us do that now. So dy by dx will be equal to, what is dy by dt? It is 2a divided by dx by dt. So this one. So dx by dt is 2at. So we have to substitute that here. Now this 2a and 2a will get cancelled and we get dy by dx to be equal to 1 by t. So dy by dx is equal to 1 by t. Now using this, we have to find d squared y by dx square, where we have to differentiate this with respect to x. So now again differentiating this with respect to x, we get d squared y by dx square, which is equal to, now what is the differentiation of 1 by t? 1 by t can actually be written as t to the power of minus 1, and the differentiation of t power minus 1 will be minus 1 t to the power of minus 1 minus 1, which will be minus 2, multiplied with the differentiation of t, that is dt with respect to x, so dx. So we have to use chain rule here because we are differentiating this with respect to x, but this is in terms of t. In that case, we have to again differentiate t with respect to x by using the chain rule method. So what will be this? This will be equal to minus t to the power of minus 2. T to the power of negative 2 can be written as 1 by t squared, multiplied with what is dt by dx. For that, we have to look into this. Already we have found dx by dt to be 2at. Now we require dt by dx here, that is the reciprocal of this. What is the reciprocal of this? It is 1 by 2at. So here, because this is dx by dt and we want dt by dx, we have to remember that we have to take the reciprocal of this, which is 1 by 2at. So we have to multiply this by 1 by 2at, and therefore what will be d squared y by dx squared? It will be equal to, we have this negative sign, minus 1 divided by 2a, and t squared multiplied with t is t cube. So this is our d squared y by dx square. Next we shall find the radius of curvature. So what will be the radius of curvature? It is given by the formula where rho is equal to, we have already written the radius of curvature formula here. That is 1 plus dy by dx the whole squared whole to the power of 3 by 2 divided by d squared y by dx square. Now we have found dy by dx and d squared y by dx square. So we shall substitute here. So first it will be 1 plus dy by dx square. So that is equal to 1 plus dy by dx square. What is dy by dx? 1 by t. So 1 by t squared will be 1 by t square whole to the power of 3 by 2 divided by d squared y by dx square, because that is the formula here we have already written. So d squared y by dx square. So that we have to substitute here. So what is d squared y by dx square? It is negative 1 by 2a t cube. So this will be equal to, so now we have to simplify this. So we can take the LCM over here, and so that will be equal to, the LCM is t squared. So now we have to cross multiply this t squared with 1. So it will be t squared plus 1, okay, whole to the power of 3 by 2 multiplied with this term. So this, when it goes in multiplication, this will come to the numerator, and so we will have the negative sign and then 2a t cube. Yes, now this negative sign can be taken in the front, and so this will be equal to minus, and this 2a is also a constant, so 2a multiplied with, now this power 3 by 2 is common to both the numerator as well as the denominator. So let us split it up. So it will be t squared plus 1 to the power of 3 by 2 divided by, now here it will be, so divided by, now here we have t square to the power of 3 by 2. So t square to the power of 3 by 2 multiplied with, now already this negative 2a we have taken in the front. So we will be left out with t cube. So that we will write here. Now if you see here we have t square to the power of 3 by 2. So now this 2 and this 2 will get cancelled. Similarly the cube, here we have t cube and here also we have t cube, and so these two terms will get cancelled, and finally we will be left out with equal to minus 2a multiplied with, this can be written as 1 plus t squared to the power of 3 by 2. And so therefore our radius of curvature rho is equal to minus 2a multiplied with 1 plus t squared the whole power 3 by 2. So this is what we have to prove. Actually in the question they are asking us to prove that rho is equal to minus 2a multiplied with 1 plus t squared to the power of 3 by 2. So we have proved that the radius of curvature is equal to this. Next we have to find the center of curvature and we have to prove that it is this. So center of curvature is given here. So let us see how to do that now. Now the center of curvature formula I have already written here. Now we are using y1 and y2 here. What is y1? It is the first derivative of y. First derivative of y means dy by dx. So what is dy by dx? Actually it is equal to 1 by t. So therefore y1 is equal to 1 by t. So we are already having y1 here. Now next we need y2 also. So what is y2? y2 is the second derivative of y with respect to x. What is second derivative of y with respect to x? It is d squared y by dx square. So this is our y2. So that we have found here and we have found it to be minus 1 by 2a t cube. So therefore y2 is equal to what? Negative 1 by 2a t cube. So let us mark that also. Now we have to substitute these two in these two formulas to find the center of curvature. So now we shall use these two formulas and find the center of curvature. Now what is this x? X is already we have taken at square. In the beginning of the problem when we wrote the parametric equation of the parabola, we wrote x is equal to at squared and y is equal to 2at. So these two we have to substitute in this formula. Now let us find capital X first. So x will be equal to, now small x is at squared. So first we shall substitute that. So at squared minus y1. What is y1? 1 by t. So 1 by t multiplied with 1 plus y1 square. So 1 by t squared divided by y2. y2 is negative 1 by 2at cube. So that we have to write here minus 1 by 2at cube. Now we shall simplify this. So this will be equal to, so this at squared first we will write. So at squared and this minus into minus will become plus. So plus, now this 1 by t and within the bracket we can take LCM here. So it will be t squared and in the numerator cross multiply here. So it will be t squared plus 1 and this which is here in the denominator can be written in the numerator because this is the reciprocal. So it will become 2at cube. Now so that will be equal to, now we can we have t and t squared here, together it is t cube. So this t cube and this 2 will get cancelled and so we will be having at squared, so this term plus, now here we have 2at, so that we can write, so 2a. Now when we multiply it here it will be 2a multiplied with t squared, so 2a t squared and then plus 2a, so plus 2a, and that is equal to at squared plus 2a squared will become 3a t square plus 2a. So this is our capital X. So therefore capital X is equal to 3a t squared plus 2a. So let us mark it. Now next we have to evaluate the y coordinate. So what is y? Y is equal to small y. So what is small y? 2at. It is 2at plus this one. So 1 plus y1 square. What is y1? It is 1 by t. So it will be 1 by t squared divided by y2. y2 is 1 by, minus 1 by 2at cube. So let us substitute that here. Minus 1 by 2at cube. So we shall simplify this. So this will be equal to 2at plus this plus into minus. It will become minus. So minus. Okay, be very careful with the signs. So plus into minus is minus multiplied with This one we can take LCM, so t squared, so it will become t squared plus 1 multiplied with, now this will come to the numerator because it is the denominator of the denominator, so it will be 2at cube. And so now we can see that here we have t squared and t cube here, so one of the t will remain here and we will cancel t squared and t squared. So this will be equal to 2at, and then we will multiply this 2a within. So it will become minus 2a t square. So the 2a multiplied with t squared. So it will be minus 2a t squared, then minus 2a. So now actually we are left out with t also here, so it will be 2at multiplied with t square first. So 2at multiplied with t squared will be 2at cube, because t squared into t will be t cube, and then plus into minus minus 2at. So this is what we get, and this 2at and this 2at gets cancelled, and finally we are left out with negative 2a t cube. So therefore the y coordinate is equal to minus 2a t cube. So this is our y center of y coordinate of our center of curvature. So therefore the coordinates of the center of curvature, so center of curvature is x comma y, which is equal to what? First we have to write the x coordinate. X coordinate we have evaluated as 3at squared plus 2a, comma, the y coordinate negative 2at cube. So this is the center of curvature. So now if you see, we have proved that x is equals to 3at squared plus 2a. That is what required here. We have to prove x is equals to 2a plus 3a t cube. In the question it has to be t squared. By mistake I have written it as t cube. Actually we have to prove that x is equals to 2a plus 3a t square. So that is what we have proved here. We have found x to be equal to 3a t squared plus 2a. And then we have to prove that y is equal to minus 2a t cube. So we have proved this here. We have proved that y is equal to minus 2a t cube. Now next we have to find the evolute of this parabola. So by definition, the evolute of a curve is the locus of the center of curvature for a curve is called the evolute of the curve. So to find the evolute of the curve, first we should write the coordinates of the center of curvature. What are they? Just now we have found the x coordinate is 3at squared plus 2a. And then the y coordinate is equal to minus 2a t cube, that is negative 2a t cube. So we have written the coordinates first. Now we can find the evolute by eliminating t from x and y. So the equation of the evolute can be found by eliminating this t from x and y. So how shall we do that now? First we will find t in terms of x. So now what is our x? X is equals to 3at squared plus 2a. So from this we can write 3at squared. Okay, we can write 3at squared to be equal to, now what will be that? It will be x minus 2a. So taking 2a to the other side, it will be x minus 2a. Now from this we will get t squared to be equal to, so what is t squared? Bringing this 3a to the denominator here, it will be x minus 2a divided by 3a. So therefore what will be t finally from this? T will be equal to square root of x minus 2a by 3a. So now this square root can be written as, so from this t will be equal to x minus 2a by 3a the whole power 1 by 2, because square root can be written as to the power 1 by 2. Now what we will do, we will substitute this value of t in our y coordinate, that is our y equal to minus 2at cube we have, no, there at the place of t we will substitute this value. So what will happen, y will be equal to negative 2a t cube we are having. So this is t. So t is x minus 2a divided by 3a. Already we have to the power 1 by 2. Now we have to take the cube of this. So cube will become 3 by 2, because cube of this t. So it will be x minus 2a by 3a to the power 3 by 2. Now we want to get rid of this square root, that is this power 1 by 2. So for that what we will do, we will square on both the sides. So squaring on both the sides, what do we get? Now y here we have, so y square will be equal to this negative sign. When we take the square, it will become positive. And the square of 2 is 4. And the square of a is a square multiplied with, now this power 1 by 2 will go away because we are squaring it, and it will be x minus 2a. Okay, this cube we will write here divided by, now here 3a cube alone we will have. So what is the cube of 3? 3 multiplied with 3 multiplied by 3, which is 27. So 27, and the cube of a is a cube. Now we will take this 27a cube to the left hand side. But before that we will cancel this a squared, and here we will have 1a. So we will take 27a to the left. So what we will get is 27a y square to be equal to, now here we have a 4. So 4 multiplied with x minus 2a the whole cube. So this is the evolute of the parabola. So we have found the evolute of the parabola. So therefore the locus of the center of curvature x comma y is given by 27a y squared equal to 4 multiplied with x minus 2a the whole cube, which is the evolute of the parabola. And you know this equation is called as semi-cubical parabola. So semi-cubical parabola. So what is the evolute of the parabola? It is the semi-cubical parabola given by this equation. Hope you have understood the complete problem clearly. Thank you.